G'day lads and ladies, and welcome to another episode of What's Up Mate podcast, a podcast for Aussie electricians and fridgies and those aspiring to be. So today it's about 8:45 here in Adelaide on the 22nd of September 2024. It's the only time I've had to actually record this podcast. I've been tinkering with some stuff in the shed over the weekend. Kids are off to sleep finally. And my wife's at work, so I've just quickly snuck out in between some stuff to get this one recorded for you guys. So what have we been up to this last week? Just the usual stuff. We actually did some help at the Adelaide Botanic Gardens. They're opening up a new restaurant in there. That's pretty exciting. That one's coming to a close with the boys from MG Group. So we did some large ducted systems, some evaporative cooler stuff also for their makeup air for their kitchens. So just done a little bit out of the ordinary, nothing tricky about it. It's just, why we use it is obviously we don't want to negatively pressurise that building. So the evaporative cooler is there to sort of make up the air that the kitchen exhaust fans are sucking out, basically. So they're controlled by a couple of VSDs, the hoods are. That was pretty interesting. Just some service maintenance stuff. Second fix a new home that another contractor started and couldn't complete his contractual requirements, so we were called in to fix it. Handover was on Saturday morning. We found out about the job last Friday. Had to install new mains, all sorts of stuff, so pretty hectic couple of days on site there with the boys. That included doing things, septic install, cutting brand new concrete paths, just stuff that's completely unnecessary. A lot of there, funny that we were actually talking about section 3 last week. I think this fella probably could have, or his workers at least, probably could have read up a bit on that. Found a lot of defects, which is sad for a brand new home, so we've had to rectify them. We've still got a few things that we need to go back and sort out with some cable covers, etc. That's pretty sad. Went out and had a look at a job for one of our good mates who's he does predominantly solar battery storage stuff. He's asked us to pop out and have a bit of a look, see if we can order some air conditioning for one of his clients. While we're there, we did a few tests. Like for these rural jobs, I really like to actually do a fault loop impedance at the main switch, just to make sure, volt drop, etc. is not going to be an issue. External fault loop impedance is not a massive issue. Obviously, we're starting to look at installing a bit of load. When we're talking, 25 kilowatt plus of cooling going into this home. So just like to dot my I's, cross my T's, all that sort of stuff, and actually found their fault loop impedance at their main switch line to neutral. It was a 2-phase property. Red phase, like 3.33 ohms, which is huge. Also, blue phase, which was 3.4, something around that mark. So we raised that with SA Power Networks. They popped out there. Got that all sorted. Clients were actually complaining about dimming lights, things like that. So if you ever hear of clients complaining of significantly dimming lights, it could be a volt drop issue. It could be indicative also of a poor neutral out in the street. So SA Power's lineys went out there. They actually found a bird's nest up in one of their big, their connection points on their poles. This was an over-under service, so basically overhead supplies in the street to a long underground run. But a bird nest had basically sat on top. So if we hadn't picked it up, perhaps in summer, maybe it would have even started a bushfire. So it's just a handy little test to do that one. I also rattled a few feathers with one of my videos once as well, about actually just checking current on your main earth. It takes not a lot of time to do that, but it'll also actually identify that fault pretty well, especially if the house is loaded up. Let's get cracking, guys and girls. We're going to talk about this. So this will be part 2 of section 3 in AS3000 2018. Let's get going. All right, so we're going to kick pretty well straight off where we left off last week. We're going to touch base on underground wiring systems. So page 192 on AS3000. Just recommend you guys having this in front of you while we just flick through these pages, so you can sort of start to get a feel of how this book's laid out. We're going to touch base on the rest of section 3 in this episode. It's a pretty big one, so we thought we'd break this section down into 2 parts. So underground wiring systems, we need to make sure that we're installing systems that are suitable for the environment in which they're placed. We need to make sure they're provided with protection against damage likely to be caused by manual or mechanical excavation work. So we have to look at the classification, like do we need to lay them in conduits? Do we need to have steel cable covers, or do we need to have encased in concrete? There's a few ways we can do that. And we also need to provide warning that that there's cables or underground wiring present in those trenches. And that's generally by the use of like a warning tape. It comes in a 500 metre roll. Or you can use that hard polymeric cable cover, which is actually pretty effective at sort of tangling excavators and things like that up. So depending on the classification of the wiring system, will basically let us know what we need to do in regards to a warning system, as well as mechanical protection, but also looking at the environment as well. So we've got 3 sorts of wiring systems, or 3 classifications of underground wiring systems. So basically the type of cable and the form of the enclosure that we're going to use is going to determine the category assigned to the underground wiring system. So Category A, a system where the wiring system is inherently suitable for installation below ground and no further mechanical protection is required. So we're going to start looking at direct buried services. The old telecom stuff is direct buried, some HV stuff's direct buried, some low voltage stuff's direct buried. There's all sorts of different examples there. Category B system, where the wiring system is suitable for installation below ground only with additional mechanical protection provided for the cable or cable enclosure. So additional mechanical protection for the cable, we would then look at a conduit, or then we've also got additional mechanical protection provided for the cable enclosure. So that's when we might start looking at installing that polymeric slab over the top, maybe some concrete, maybe encasing it in some steel. So there's all sorts of different options. So we've got a table. Underground cables shall be basically of a type specified in column 1 of table 3.5, and also installed in accordance with the categories specified in columns 2 to 9 of table 3.5. So underground, it's a pretty key note here. It says, note, underground wiring systems do not include those that are embedded in a concrete floor, slab or pad. So that's inside a building. Laid on the surface of the ground, either within the building or in outdoor locations. So we could look at in an office, they've got that cable trunking that lays across the top of the floor. Same with we just had the Royal Adelaide show here, and you'll see I've got a really good mate of mine who actually works at the showgrounds as a sparky. That's a whole different standard, but they've got cables that get put over the top of the ground and then covered up. It's not an underground wiring system. Enclosed in a ventilated cable tunnel. So I've also got a good mate who's done a lot of work up at Mount Lofty, so where the broadcasting towers are. They've got cable tunnels there, and you can actually lay on your guts and go for a bit of a crawl underneath. You're underground, but because it's a ventilated cable tunnel, it's not deemed for being underground wiring. And there's like cable trays and all sorts of stuff in there. It's pretty cool. Also enclosed in a trough with removable covers where air circulation is not restricted. So there's just a couple of, exemptions there for what is an underground wiring system. So here we go. Category A, underground wiring system. Category A, underground wiring systems recognised by this standard comprise of one of the following arrangements. So a system where cables are enclosed in heavy-duty insulating conduit without further mechanical protection. Now that one's super common, probably one of the most common. A system where cables are enclosed in insulating wiring enclosures encased in concrete. So we occasionally need to put concrete over the top of cables. Years and years and years ago, I did one where an excavator damaged somebody's consumer's mains that crossed through a creek. So we need to encase our consumer's mains in steel, but then also in concrete as well. So that was a pretty big job to do that in a flowing creek as well, which made it really tricky. But yeah, we spoke with a technical regulator about that, and they gave us some guidance, so it was pretty good. A system where sheathed cables are enclosed in galvanised steel pipe without further mechanical protection. So just a note here, metal conduits are not suitable for this purpose. A system where armoured sheathed cables or neutral screen cables are buried direct in the ground without mechanical protection. So that's that direct buried. Category B underground wiring systems. So recognised by this standard, they comprise of one of the following. So a system where cables are enclosed in medium duty insulating conduit with additional mechanical protection. I've never done that. A system where sheathed cables are buried direct in the ground with mechanical protection. So that could be that polymeric slab over the top. Mechanical protection for a Category B underground wiring system is detailed in Clause 3.11.4.3. And it gives us a few extra examples of in some figures. So again, it's very visual, these figures and tables here. So I definitely recommend having a bit of a look. And then we've got a Category C underground wiring system, which is basically underground wiring systems chased into rock and covered with concrete. So I've only ever done that once at a job in Aldgate as an apprentice many years ago, and it was an absolute nightmare. So yeah, if you come across one of them, maybe get a contractor in to do that one. So table 3.5, underground wiring system categories. It's going to give us method of protection of the cable. It'll give us a heavy duty conduit, and all the way down that column, that'll be what category it's rated at. We've got insulated unsheathed conductors in heavy duty fibre cement conduit. That's not permitted. So it gives us, but if it's insulated unsheathed conductors in medium duty conduit encased in concrete, it's a Category A wiring system. So there's a heap of different examples. So if you're not sure on what category wiring system you are installing, just head on to this one, table 3.5 on page 195. It'll point you in the right direction. Installation requirements. Underground wiring systems shall be installed in accordance with the requirements of clause 3.11.4.2 to 3.11.4.6. Just noting that typical arrangements of underground wiring systems are shown, and measurement values also apply to any direction where the cover is relied upon to minimise risk of excavation. So just have a good look at that, because depending, like you're digging on a hill, your cable cover from the surface, it's a vertical measurement, not one on an angle. So you've got to go a little bit deeper. Just a few little things to look at on that. Unenclosed cable, so any Category A or Category B wiring system that comprises cable not installed in a wiring enclosure shall be laid on a bed of not less than 50 ml of sand or friable soil, free of sharp stone and covered by not less than 50 ml of the same material. So a lot of the time we might be thinking about doing direct buried without that additional sort of conduit work, but you got to think of the extra costs of getting in quarry sand or machinery to move that sand around, maintaining that 50 mil, over excavating to get your cover as well, to then add 50 mil of sand on. Then you've got excess soil to remove from site. So it's although it sounds like a really good thing, like you save a bit of money on conduit. Like conduit can be quite expensive when you're buying thousands of meters of it, but so can diesel, burning, running bobcats, tipping trucks, all that sort of stuff, just to do that direct buried option. So there's obviously that tipping point where it becomes more viable to do it. Category B wiring systems mechanical protection. The protection shall be placed not more than 75 mil above the wiring system. The protection shall not be less than 150 mil wide. So it's giving us some examples of, well, not giving us examples, it's telling us how we need to have this additional cover. The protection shall overlap the wiring system by at least 40 mil on each side. The protection shall consist of one or a combination of the following. So precast concrete slabs having a thickness of not less than 40 mil and a classification of not less than grade 20 in accordance with AS3000 or NZS 3104. Concrete slabs cast on site having a thickness of not less than 100 mil. A continuous concrete pour having a thickness of not less than 75 mil. So, it's a lot of concrete to be putting over your cables if you're going to go this category B system. Fibrous cement slabs having a thickness of not less than 12 mil. Bricks manufactured specifically for the protection of electric cables. Polymeric cable cover strips complying with AS3002. So in SA Power Networks have requested that we use that for our Stobie pole connections or our pole connections for our consumers' mains. I think it's a good idea because otherwise you end up spending a lot of time jackhammering up the foundations for their Stobie poles, etc., which obviously isn't ideal when you're compromising that. We get some pretty good storms here. We also get the odd carver Stobie pole too. So we want to make sure that we're not compromising those foundations. We can also use any other material that offers the same degree of protection afforded by the materials in items 1 to 5 or 1 to 6 that I've just listed. But how do we define that? That's a very tricky one. You're probably opening yourself up to all sorts of trouble, and it's not going to be trouble straight away. It's going to be trouble when somebody else digs it up. I learned a lesson, a pretty expensive lesson actually, not by our fault. So we did a big job up in Stirling, where brand new house being built, huge house, beautiful home, which were the contractors for that. We did that, and no dramas. Part of the work was the retaining wall for the block was going to start to encroach on the neighbour's easement that ran up the side, which their sewer and their power went through. So part of our scope of works was to relocate their consumers' mains while the plumbers relocated the sewer. Not a drama, did that. Then the landscaping company came through and over-excavated and hit the consumers' mains. Even though they found our trench tape first, they still hit it with a 20-tonne excavator. Caused all sorts of dramas. Arguments over who was going to pay, which really shouldn't have been an argument. Insurance should have paid that. A whole mess up there. But because we follow the standards, thankfully nobody got hurt when they did it. But if somebody did get hurt and somebody hit our cables, despite them digging in the wrong location, if we didn't have that trench tape and we didn't have those photos of the trench tape, we didn't have that. The cable was particularly mechanically protected, and somebody got hurt or worse, passed away, and we can't prove that we met these standards. That's when it becomes a real issue when they say, you can use other materials that meet the classifications listed above. How do we know that's going to meet in a court of law? How do we know we're going to be covered? So it's just something to think about when you're starting to really stray away from what they tell us what we can and can't do in the standards. Minimum depth of cover. So we need to look at the minimum depth of cover depending on the system that we're installing. Table 3.6 gives us that. For some reason, there was always a 600 mil rule. Well, people thought it was, you had to be 600 mil. It's actually 500 mil to the top of your conduit. I think it stemmed from an old SA Power Network rule where consumers' mains had to be 600 mil deep. Sometimes the deeper the better. Just bearing in mind that heat resistivity of your soil is going to start to affect your cable current carrying capacity, which is listed in our AS3008. So again, it's one of those things. Plus, you don't want to be digging deeper than you need to and disturbing more soil, especially if you're doing it by hand. No one wants to dig deeper than you need to. So table 3.6, have a bit of a look. Basically, if you've got 75 mil of concrete on top of your cable, you can dig to 300 mil deep. So that's your depth of cover. So if you've got a 40 mil conduit, you have to be 340 mil deep. So it's not, I'll dig to 300 and call it job done. You don't have that cover. If you only go 300 deep, you've only got 260 mil of cover. So you just always have to go add that extra width to your conduit or your largest conduit if it's a common services trench. So identification of underground wiring. So wiring system installed underground shall be identified by an orange marker tape complying with AS/NZS 26481. Just grab it from the wholesaler. It's 150 mil wide. It basically provides early detection of the presence of an underground wiring during excavation work. Basically, marker tape needs to be positioned at approximately 50% of the depth of cover above the wiring system or any additional mechanical protection provided for that system. So let's say we've dug a trench a metre deep because they might be doing some retaining walls, etc. later. We backfill halfway, we put our tape down, then we continue backfilling. If we've dug 300mm deep and we've put 340mm deep, say, and we put some 75mm of concrete on top, we then need to backfill halfway above that, then warning tape. So the idea is if an excavator's coming through to grabbing like full scoops out, they hit the tape, bring the tape out, and they haven't got anywhere near your cable. That's the idea of it. We don't want to see, which we do see a lot of, conduits without marking tape. Like, it's not always been a rule to have marking tape. But even some new builds, you come across cables that aren't installed correctly with no marking tape, etc. It's just lazy. It's a requirement. And I kind of wish plumbers used marking tape for stormwater and stuff like that, because I was on the excavator during the week and hit a couple of pipes and it made an absolute mess. Thankfully, the plumbers we use are brilliant dudes. They just come through behind us and fix what they can. And we obviously try and avoid it, but sometimes it's a bit tricky. Like, you don't expect to come across pipes in some scenarios, and then you come across two in the space of a couple of metres. It's a bit frustrating, but it is what it is. Marking tape could avoid that. So marker tape may be omitted where an underground wiring system is installed by boring. So that's where you bore under people's driveways or under roadways. So you can only do that if you're going to mark, the location of that wiring system is marked and recorded in a suitable permanent location. So a good idea for that is just marking your switchboard, which is a requirement anyway for consumers' mains, but it's also a requirement now if you're doing boring to do that for submains, anything like that. If an enclosure is retained after boring operations, the enclosure is coloured orange, so just to make sure that any enclosures that's brought through that boring path is orange. So you'll see a lot of the big orange rolls of conduit on larger trailers, generally following boring equipment through. That's what they put there through to sleeve it. So it's a pretty good one. It's actually really handy. We've used a boring company. He calls himself the Grundy guy. He's a bit of a guru. He's done a few very tricky jobs for us and quite reasonably priced, and it's just incredible what he can do with that machine. So on page 198 we've got a few examples, 199 also, of how the wiring systems that we're using, how we're going to mechanically protect the cable, etc. So I'm not going to run through these. Recommend having a bit of a look. Like, it gives you some indications of like where your marking tape needs to be, how you're protecting your conduit, how you protect encasing it in sand, direct buried, all that sort of stuff. So it's really interesting. So it gives you an example of underground wiring systems like sloping ground, underground wiring system like category C, category B wiring systems, category A. Like, it gives you a list of them all, a couple of examples. So if you're not sure about something, 9 times out of 10 what you're doing will be found in here. So marking and recording of underground cable location, we've touched that for boring. Basically, to minimise damage to underground wiring systems during manual or mechanical excavation works, the location of underground wiring shall be marked or recorded as follows. So permanent cable marker signs shall be provided to indicate the point where a cable enters or leaves a structure. Exception there, cable entry signs need not be provided where the position of underground cable entry into the ground is obvious. Or the route of any underground cable shall be recorded on a plan to enable the location of the cable to be determined in the future. This plan shall be located at the switchboard from which the circuit originates. The plan locating the consumer's main shall be kept at the main switchboard of the installation to which it is connected. So that's actually part of the service and installation rules. And SA Power Networks won't connect if you don't have that plan in there. So marking of underground wiring is not required within the confines of a building. So if you've got precast slab going in, tilt-up building, and you've run all your conduits within the confines of the building, and just popping up at the outer extremities just before the concrete poured. You don't actually need to mark those cable routes. By all means you can. This is just a minimum standard, but it's basically expected that if you're going to be cutting up concrete inside of a building, that do your due diligence. There's likely going to be conduits, especially in commercial buildings, under that slab. And there's those cable locators and the earth radars, etc., that can all do that sort of stuff pretty effectively and cheaply for you. So spacing from other underground services. All underground wiring systems shall be spaced not less than 100mm from other underground services. Other services, like if you're running multiple submains cables, technically it's the same service because we've got it's the same. So we're electricians. We install electrical. Electrical is the service. Wiring system shall be suitably marked with a warning tape. We've already discussed that. Again, AS3000 likes to repeat itself. We need to maintain separation from telecommunications, gas and water services in accordance with Table 3.7. Further requirements for the separation of telecommunication, gas and water systems from low voltage wiring systems are provided in Clause 3984. So basically it says here water services not greater than DN65, so 65mm is the internal diameter of the pipe, not the external diameter of the pipe. Low voltage, we want to be 100 millimeters, and low voltage electrical earthing electric, we want to be greater than 500 millimeters away. Anything greater than DN65, so 65mm internal diameter, we want to be 300mm away and 500mm from an earthing electrode. Now, a lot of people are like, oh, why do we need this segregation if it's not a conductive thing? It's basically, if the plumbers have to dig it up, or if the gas guys have to dig this stuff up, because there's a leak or something like that, they don't want to be wrestling in a trench with and not being able to get their tools in around our conduits. It's just that nobody likes working on top of other services. It's even harder when it's in the ground, especially if it's a leaky pipe. You got mud, you got cables running through, you got all sorts of stuff. You want that bit of separation. So here the exception, so I've already touched base on it. 2 or more underground wiring systems may be grouped together where they are associated with the same electrical installation. So the requirements of this clause, so clause 311.5, may be varied where a number of services are installed touching in a common trench, provided that each service is installed in a separate enclosure that identifies the service. So that's why our conduits are marked electrical or communications or Telstra or NBN. Separation distance between conductive enclosures and the earthing electrode are not required where all conductive enclosures are bonded within the installation. So it's only really an issue when we've got multiple installations with conductive conduit ways that's when it really becomes an issue with our separation, because we don't want to get stuck in those circulating fault currents in the event of potentially a neutral fault, especially. Aerial wiring systems. I've not done a lot of aerial stuff, to be honest. We've done some years ago as an apprentice up the Riverland, and the birds ate it all. So it's really important to make sure you're picking the right cable for that. I never would have thought that birds would just destroy overhead cables, but they do. It was during a big drought though, so I think they were not a lot of actual food out there for them. So I think that's probably why they picked on it. Aerial wiring systems. So the use of aerial wiring systems may be prohibited by the relevant regulatory authority in some areas, particularly those areas at risk of bushfire. So after the KI bushfires here in SA, the Cuddly Creek ones as well, a lot of that overhead infrastructure was damaged quite severely. So SA Power Networks had a huge job ahead of them to go through and repair all that. There were a few contractors that took the piss a bit and made a lot of money on those 2 disasters. So they've it's good that they're sort of starting to think about, we live in a pretty fire-prone environment. Let's not install stuff that's going to cost a fortune to fix later. So types of conductors need to be hard-drawn, bare conductors, polymeric insulated cables, neutral screen cables, or parallel web twisted or bundled insulated cables. Now, I've not done a lot of aerial wiring systems, so I'm not going to pretend to be a pro. I think this probably is going to, like maybe your level 2 guys in the eastern states, probably do a lot more of this stuff. In SA, there's only really 2 or 3 contractors that deal with the aerial stuff for distribution. That's SA Power Networks, and there's 2 others. I won't mention them, but SA Power Networks is the biggest player in that field for us. Installation of aerial conductors, they need to be insulated for any conductor span that is attached to a building or structure. So the old overhead exposed lines are no longer compliant. They don't have to be changed, but if you're doing an upgrade, that's when they'll need to be changed. Any conductor span within arm's reach of any building or opening or structure. Again, we don't want to be touching live parts. We've discussed that in section 2. So also like crossing rivers, creeks, irrigation pipes, etc. Like anything with like long booms, can't be uninsulated, because you don't want a sailing boat on the river to come through and hit some exposed wiring up there. And again, here it says in areas declared by the responsible fire authority as being subject to bushfires where required by the regulatory authority or the electricity distributor. I guess there's a few farms and stuff out there that still use overhead wiring systems. Got another good mate who's a spark. He does a lot of rural stuff. A lot of farmers are asking to get all their overhead stuff removed because it's a danger, like it's a work health safety danger issue for them. They're moving huge equipment around. They're harvesting at night now, making the most out of their equipment and their labour rates, etc. They just can't afford to have tractors hitting this stuff. So I think aerial stuff certainly, although it sounds like it's going to be easier, from a safety point of view, wouldn't probably recommend. Minimum size of aerial conductors, copper and aluminium conductors installed as aerial conductors shall have not less than 7 strands and shall be not smaller than 6 mil for copper or 16 mil for aluminium. So I guess if you're doing aerial, it's probably a long run, so you're probably going to be up above that 6 or 16 mil straight away anyway. I believe it's more of a mechanical strength. Obviously, we've got issues like with wind movement, tree branches falling on things. We want some form of mechanical strength. Like we've got birds landing on them. Imagine how much a whole flock of big black birds, like those big black cockatoos, they're massive. Imagine them landing on something smaller than 6 mil, like it's just going to snap. And then depending if it's the submains, it might not even be RCD protected, it might not even trip that circuit protection. I've seen in storm events as a fiery, transformers sitting on the ground basically just arcing. It's pretty full on, like leaving burns through the asphalt. Even one up our road the other week, like we had a big storm blow through, and just seeing that the large copper overhead conductors we've got here, just glowing red as they're shorting out. So a lot of current can flow before any protective device operates. So we want to make sure it stays up in the air where it's intended and it's safe. Steel conductors installed as aerial conductors shall have not less than 3 strands. I've never seen a steel conductor. No, I've seen steel like guide wires for stovey poles and telecom towers and things like that, but I've never seen a steel conductor. Aerial conductors, we need to have a look at obviously clearances. 115 degrees is a pretty interesting clearances shall be maintained in any direction from any position to which any part of such conductors may either sag at a maximum conductor temperature of 115 degrees or more as a result of wind pressure. So obviously wind is going to be pushing, the cables can stretch, all that stuff, but we just need to make sure. And that's why you'll see a lot of the SA Power Networks, or there's the helicopter mob that cruise around as well. with the special measurement devices, seeing how low the cables, like cable sags, etc. So it's a big thing to do. Like aerial, there's a lot of like more maintenance with aerial stuff, I reckon. Like keeping trees away from it. You get possums running up and down it. You get birds landing on it. Storm events. I've seen trampolines end up in high voltage lines. Bushfires start, like the Cuddly Creek bushfire was started by overhead power lines, which was a huge liability case for SA Power. All sorts of stuff around those aerial conductors. So in my opinion, if it can go underground, it's safer underground. It might be a bit more work, but in the long run, I think your client's going to save. Really thank you for doing that extra work for them. So we got safety warnings and stuff like that. Above areas used by sailing craft, like you'll see on the sides of the roads as well now, like around construction sites like Aldinga Way. At the moment, they're doing huge road upgrades there. You'll see a lot of like little yellow cardboard cutouts, or I don't think they're cardboard, but basically indicating there's power lines overhead. Basically, anything with heights. Conductive piping, like irrigation pipes, is a huge thing, especially down the southeast. I remember growing up down in Keith, and the length of those aluminium irrigation pipes were so long, and you could pick them up pretty easy because they were empty. But we had exposed conductors running between buildings, and it would be pretty easy for you to lift up one of those irrigation pipes and smack it into those power lines. My great uncle, actually, the roll bar on his large tractor up by their dam caught a uninsulated overhead power line, and yeah, he survived. It was wet. His tractor tyres, all four of them burst, all sorts of stuff. So if you do come into contact with anything with your vehicle, obviously wait for authorities to come and help make sure you can prove for dead. We've got issues around step voltage and stuff like that if you get out. So it tells table 3.8 on 206 is giving us some aerial conductor clearances. So bare live conductors over areas used by vehicles have to be greater than 5.5 metres. And they have to be 1.2 metres away from telecommunication lines. We don't want any like low voltage or high voltage lines coming down and shorting out on any sort of telecommunication lines. Especially we've got those telecom lines, we've got that steel trace cable in them to support them. So we want to be careful about that sort of stuff. Again, I think that's more of a like service and installation rule for like the guys hooking our buildings up to the network. I don't think that really falls on us as electricians anymore. Aerial conductor maximum span. So if you are designing something, it'll give you some maximum spans. There's also some appendixes. I can't remember exactly which one they are. And here it is, Appendix D. It'll give you some spans, etc. It'll also tell you what sort of sizing for your support, so for like any poles and stuff. So if you are going to do some stuff, definitely recommend having a read through that. If you don't want to put something undersized and it bends or snaps or whatever, or you put your ladder up there to start to support it, and you all of a sudden start seeing the ground coming closer and closer to you as your pole you've put up can't even support your own weight. So it's certainly an interesting thing. Like, we don't do a lot of it. It'll give you spacing between aerial conductors it supports. So like 200mm, 300mm, 400mm, 500mm, like all dependent on your span, because obviously you don't want your conductors clashing in wind. Joints and connections, again, I'm probably not going to chat to you about that because that's, again, I'm definitely no expert on that. So cables supported by a catenary. So types of cables. Cables supported by means of a catenary shall be stranded cables affording double insulation or the equivalent of double insulation. So you can run like single insulated cables through a conduit, bearing in mind that if it's out in the weather, your conduit will probably crack over time. Cables and catenary supports installed out doors shall be suitable for exposure to direct sunlight. I've seen all sorts of stuff like bundles of like data run inside like 50mm medium duty conduit, like not sheathed stuff. And it was all so badly deteriorated at the top that the only bits of conduit was on the bottom where the UV hadn't hit, and where the cable ties were sort of wrapped around the 50mm to the catenary. There's like a small slither of very brittle conduit, and then the cables, all these blue data cables linking all these buildings together, were just so sun damaged and filled with water. I honestly can't believe they were still working. So we need to make sure that whatever we're putting up there is going to be rated to be out in the sun. Catenary support shall basically provide uniform support. We don't want undue sagging. We don't want anything that's going to corrode or deteriorate. We need it to be effectively fixed at each end, capable of withstanding mechanical stresses likely to occur, in particular those because of wind or ice. So we get a lot of wind up here. We don't get much ice, thankfully. But like places like, Mount Buller, things like that, like you got to think of that ice, that loading. Same with snow, because it's extra weight we're trying to support. We need to make sure we also mount it at a suitable height so it's not going to get impacted by cars or people walking. So it gives us some clauses for like neutral screen cable for clearances. We also need to make sure we're at more than 100mm away from any moving parts or parts of equipment that are operating at an elevated temperature. Safety services. So wiring system for safety services shall, in addition to complying with this section, be installed in accordance with the requirements of clause 7.2. So that's section 7. We haven't touched base on that yet. Busways, including rising main systems, so busbar trunking systems, busways shall comply with AS/NZS 3439.2 or AS/NZS 61439.6 and shall be installed in accordance with the manufacturer's instructions. The only busways that I've ever seen are actually at Tonsley TAFE. They've installed them for their safety service systems, for their lifts and things like that. I've never installed them. Earth sheath return systems, so ESR systems. The earth sheath return system is one where the copper sheath of a MIMS cable forms a single conductor that is used as both a protective earthing conductor and a neutral conductor system, a neutral conductor simultaneously. Again, I've never used MIMS cable. I think we terminated a bit of it at trade school a long time ago, when I was at Regency TAFE. It's important there to note that only a copper sheath may be used as a combined protective earthing and neutral conductor, so PEN conductor. These cables shall be installed in accordance with 3973 and the following. The sheath shall be of adequate cross-sectional area and conductivity. So again, we want to make sure that we can carry the neutral current and we can carry any potential fault currents that may occur. So we still need to test that fault loop. The ESR system shall be used only in electrical installations where the MEN earthing system is used. It shall commence at the location where the neutral and earthing conductors are connected to form the MEN connection. There's a lot of rules around this. Where the combined protective earthing and neutral conductor is changed to provide a separate neutral and protective earth to electrical equipment, the neutral and protective earth shall not be combined again to form a combined protective earthing and neutral conductor. We don't want to see parallel paths for fault currents, and we certainly don't want to see any normal operational current flowing on any earthing conductor, so that's why we don't do that. Same as why we need to make sure we don't run MEN links if we've got conductive water piping linking buildings, or if we've got a main earth running with the submain. You'd be surprised how many times we see that, because that earth then becomes a conductive path. And it will basically share that neutral current, which can be very dangerous when you're plumbing, cutting into an earthing conductor, etc. So there's a lot of things that we need to look at when we're going to use these ESR systems. I've never done it. I'm not going to pretend I'm a guru at it. Just going to be important to note that if you're going to use a ESR system, it can't be protected by an RCD. Because obviously your neutral and your earth are sharing the same sheathing, it'll trip. So we need to just make sure that we are installing that cable in a specific way where it's not going to be required to be protected by an RCD. So that's section 3 done and dusted. So next episode is section 4, selection and installation of electrical equipment. I hope you are all getting a little bit out of this as you read through it all. We've had a lot of people say that they've not got there's no real, I guess, Australian content out there, especially in regards to AS3000, or I guess even being an electrician or a friggy specifically for Australia. We work in degrees Celsius. We've got different standards for our wiring. We've used different frequency for our electrical distribution. There's so many different things like specific to Australia that I feel we need to give better education on. TAFE or PEER or ATEC, but because we work in such a fast changing industry, by the time they've caught up with what's happening in the industry, they've really fallen behind. So if we don't have education that's easily accessible by our apprentices or even our tradesmen that want to become better tradespeople, we're just going to fall behind. So that's probably one of the main motivators for this podcast is I feel like if you don't keep your finger on the pulse, you're going to fall behind pretty quickly. And once you fall behind, it's like in anything, you fall behind in a maths class or something like that, or you fall behind at trade school. It's really tricky to then catch back up. So if you've got any specific content that you want me to sort of touch base on, if you've got any questions, reach out through the Instagram page. Reach out. If a lot of you guys know me personally, flick me a message, jump on Facebook Messenger, whatever you need to do. If you've got a question, don't be afraid to ask. But I guess it took me a long time to realise that asking questions is a good thing. I was a bit stumped on a motor project I was working on. So Trevor, we've done a bit of work together over the years. He's a bit of a motor guru. I reached out to him and he helped me get a little special motor for a lathe up and running properly for a client. I didn't know everything, so I asked a question and he thank God he helped me out, because I was up until 2 a.m. Fiddling around with it, just trying to get this stuff working for a client. And I said to the client, I said, look, I'm not 100% certain on this, but hey, look, I'm going to take this home. I'm going to work on this in my own time, and I've got it back up and running for him. I learned a heap by stripping that motor down, centrifugal switching, all that sort of stuff, just to actually strip it apart. And you talk about it at trade school, but unless you get your hands on it, I don't think you quite grasp exactly how it works. So it was good for me to rip that apart. Whether or not doing it at 2 a.m. with some music going in the shed by myself was the best time to do it. It was the only time I had left. I've got 3 young kids, business, and volunteer a lot of my time, and my wife does shift work, so time can be quite a valuable asset. So sometimes you just pull an all-nighter to get stuff done. And I don't know about you guys out there, but I think the Christmas rush has really started early this year. We are under the pump at work. I mean, it's a good thing, but it's a skills shortage. I'm not sure if that's the right thing. I think it's clients' expectations are all of a sudden so through the roof. They want things because they can go on Uber and order food. It's on their doorstep within 15 minutes. It just feels as though clients are expecting that sort of service from tradespeople, which, we can answer a phone straight away, but we can't get to site straight away. And I find it really tricky. A lot of clients want me as the boss to be there to do the work. And I'm like, hang on a second, guys. I've trained all my guys from apprentices up. They do as good, if not, most of them probably can do better work than me. Why do you need the boss there? the boys work faster than me. They probably work harder than me. They're fitter than me. They're younger than I am. They're not distracted by 40 phone calls a day. So I guess whether as business owners, tradies, apprentices, maybe re-educating the clients could be the next move to sort of help release some of that stress. But yeah, we'll see where this summer season and this bushfire season takes us. It normally gets pretty hectic this time of year. So thanks everyone for listening. I jabbered on a bit there at the end, but I think it's all relevant. So if you've got any questions, comments, concerns, definitely reach out, guys. We'll move on to section 4 next week. I might do some tech talk stuff, just some short episodes in between all this. I get a little bit bored about reading through the rule book, to be honest. But yeah, thanks everyone for listening. Have a cracker week out there, guys. If you've got any questions, shout out. Don't forget to like or subscribe to this podcast, because it's going to help sort of grow the channel and help other techies get ahead of the game. But yeah, this has been you've been listening to your host Jake Sparrow from What's Up Mate, a podcast by Aussie Techs for Aussie Techs. Catch you guys.